Let's begin by recapitulating the last video on the semantic conception of reality. The conception is very simple. Everything can be modeled as a word rather than as an object. The object modeling of reality is incomplete, but the word modeling is complete. Even a person can be modeled as the word I. In fact, everything is a person, including what we consider inanimate objects. The capacities in an inanimate thing are far lower than those in humans. But even inanimate things have choices because at different times, places, and situations, different inanimate things trigger different ideas within us. If we take Newton's story of a falling apple literally, the same falling apple did not inspire everyone else to create the laws of motion. Due to the capacity in inanimate things to inspire, cajole, teach, and instigate us, we have to treat them as persons. As a result, what is currently being modeled as an object is modeled as a person in the semantic view. Since most people might wonder how we can study persons scientifically, we gave the answer to that question in the previous video. The answer is that each person tries to give themselves different kinds of meanings because they don't know the ideal meaning of their life. Their attempt is like a pen trying to realize its true nature by trying to be a toy, weapon, paperweight, or doorstop before coming to the conclusion that all these are non-ideal. A pen is ideally just a pen. Everything else, while possible, is not ideal. Thus, each person tries to give themselves varied meanings, and by that process realizes that these meanings are non-ideal. Ultimately, through this process, an ideal meaning is discovered. Both ideal and non-ideal meanings are the meanings of the word. The succession of non-ideal and ideal meanings constitute the trajectory of finding the true meaning of a word. It can also be called the process of self-discovery. The semantic view creates an alternative science because science studies trajectories, and an alternative kind of trajectory is created in a semantic science. In modern science, trajectories are constructed by objects acquiring different properties. In a semantic science, trajectories are constructed by words acquiring different meanings. The laws of these two kinds of science are different because the laws of modern science are devoid of meaning and purpose, while the laws of a semantic science are based on varied meanings and the purpose to find the ideal meaning. This is not just metaphysics, philosophy, or religion. In the last video, we discussed 6 different paths through which we arrive at this conclusion, each of which is based on observation and reason. We also talked about what happens when we disregard this view, namely, that it leads to mathematical incompleteness and the indeterminism of all sciences. Such failures are present in quantum theory too. The theory is incomplete and indeterministic. Therefore, all the principles of semantic reality can be used to understand the problem of incompleteness and indeterminism in quantum theory. And that is what I will do in this video. My goal here is not just to interpret quantum theory as has been fashionable over the last century. Interpretations of quantum theory don't solve the problems of quantum theory. They take the theory as the final state of reality and use an interpretation to make the theory more human accessible. All such interpretations are mere personal opinions. But the semantic view of reality is not such an interpretation because we don't have to consider the present quantum theory as the final state of science, let alone the final understanding of reality. Rather, by applying the semantic principles, we can show why the quantum problem arises and what the solution to that problem is. Explaining the problem and the solution is the primary goal here. The basic problem of probabilities in quantum theory can be understood as the result of trying to use the pen as a toy, weapon, paperweight, or doorstop. This probability is not constant. It changes with time, place, and situation. Quantum mechanics just talks about the change in probability with time. That is because quantum mechanics is not yet integrated with relativity theory. If such integration could be done, then we will find that the probabilities change not just with time, but also with place and situation. We will discuss the effects of relativity on quantum mechanics in subsequent videos. Right now, quantum mechanics studies an isolated ensemble of matter rather than accounting for the effects of external factors on the ensemble. Factually, matter is not so isolated. Therefore, when that isolation is removed, then probabilities will be dependent on place and situation, not just dependent on time. Sometimes the likelihood of using a pen as a toy is very low, and at other times it is high. This is the result of the fact that a pen is not just a pen. It is rather also a toy, weapon, paperweight, and doorstop. But each such use is not equally likely for all times, places, and situations. The essence of the quantum problem is that physics has since Newtonian times tried to model the world as objects when it should be modeled as words. Objects have fixed properties, but words don't have fixed meanings. Objects are independent of each other, but words are defined in relationship to other words. All the properties of objects can be measured simultaneously, but all the meanings of a word cannot be known simultaneously. Objects are governed by deterministic laws, but words are governed by the choice to interpret it in one of many possible ways, although not arbitrary ways. Objects are always things in themselves, but words are things about other things. As a result of these simple differences between objects and words, all scientific theories rooted in the study of objects must fail. Quantum theory is just that class of failures due to the attempt to model reality as objects instead of words. Classical mechanics is the study of independent objects, but this model of nature has failed because reality is not independent objects. Each thing is actually a collection of possibilities which become more or less likely in different times, places, and situations. Since the likelihood of each possibility changes with time, place, and situation, therefore each quantum ensemble is entangled with its environment and cannot be an isolated independent entity. Likewise, each possibility within an ensemble affects the other possibilities. A pen that can be used as a doorstop or paperweight is different from a pen that cannot be used in this manner. We can illustrate these differences between classical and quantum behaviors with intuitive examples about the nature of atoms or quanta. Since antiquity, it has been believed that we can divide big things into smaller things, and by such division, we will get the most fundamental ingredients of reality. It has also been believed that the small thing will more or less be like the big thing. Finally, since the big things were called particles and waves for a long time, therefore the small things must only be smaller particles or waves. All these assumptions of classical physical thinking have failed in quantum theory. To understand these failures, let's illustrate the difference between classical and quantum mechanics through the examples of geometrical shapes. Suppose we have four such shapes, namely a hexagon, a pentagon, a square, and a triangle. We can make a set of these four shapes and call that a whole. Set theory is the foundation of modern mathematics. Therefore, we are just following the basic manner in which modern science thinks. In a set, each object is independent of the other objects. Hence, if we remove the hexagon from the set, the pentagon, square, and triangle will still be intact. If we then remove the pentagon from the set, the square and triangle will still be intact. Finally, if we remove the square from the set, the triangle will still be intact. This is how classical physics has always conceived of matter, namely, that each part is independent of the other parts. If we remove one part, the other parts remain intact. When mathematics is used to model reality, then the set theoretic assumptions about reality as independent parts are inbuilt into science. To understand the problem with this thinking, we can substitute the whole set with a shape like a hexagon which has 6 sides. If we remove one side from the hexagon, the result will be a pentagon in which all the remaining 5 sides will be modified. If we remove one more side from the pentagon, then the result will be a square in which all the remaining sides will be modified. Finally, if we remove one more side from the square, the result will be a triangle in which all the remaining sides will be modified. This is how quantum mechanics forces us to think of reality, namely, that no part is independent of the other parts. If we remove one part, then each other remaining part is changed. All these parts are not like the separate shapes, such as hexagon, pentagon, square, and triangle. They are rather like the faces of a single shape, such as a hexagon. Therefore, classical mechanics treats reality as parts, while quantum mechanics forces us to treat reality as faces. Atoms are not independent parts of an object. They are rather faces of an object. If we remove one face, we don't just change the whole, we also change each part because no part is classically separable. Quite similar to the contrast between parts and faces, we can also illustrate the quantum problem by another contrast between objects and dimensions. In classical physics, matter moves in a fixed three-dimensional space and is ontologically separate from space. If we remove one particle from a system, we don't change the structure of the space. The removed part only acquires a new position in space. However, in quantum physics, each particle is like a dimension of space called the Hilbert space. If we remove a particle, we reduce the dimensionality of the space. These dimensions are also mutually defined. Therefore, if we remove a particle, the new dimensions do not remain unchanged. Rather, every dimension changes as the result of removing one dimension, quite like every face of a geometrical shape changes when we remove one face. As a result, we cannot keep matter and space ontologically separate. Rather, matter is a dimension of space. If we remove matter, then we reduce the dimensionality of space. If there are 100 quantum particles in a system, then the system is 100 dimensional. If we remove 10 particles, then the system is 90 dimensional. But those 90 dimensions are not the same 90 dimensions as they were before the removal of 10 particles. Rather, we get a new and different set of 90 dimensions after removing the 10 particles. This situation can be understood by the working of a team. If one member joins a team, then the existing work is divided into a larger group of team members, and each person gets a more focused work. But if one member leaves, then the existing work is again redistributed within the larger group of team members, and each person now gets a more diverse type of work. Thus, the work of the team remains the same, but with more members, each member does more focused work. With less members, each member does more diverse work. This principle of teams dividing the work among themselves is seen in each living person. For example, if a person was to lose a finger, then he will redistribute the work of that finger onto the remaining fingers. He will still do the same work, although he might be slowed down in that effort. Similarly, if someone loses both their legs, then they will redistribute the work of the legs onto the hands. The same work will be done, although often slowly, because the hands are now doing the work of both hands and legs. Finally, if the person lost both hands and legs, then he will try to move some of the work to the teeth. Thus, removing a part doesn't immediately diminish the body's capacity. Rather, as far as possible, the work is redistributed. It is only in extreme cases that certain types of work that cannot be done. Handicapped people sometimes add prosthetics to compensate for the previous loss. That prosthetic may or may not work precisely as the missing body part, but it helps a person attain the previous levels of productivity to the same extent. Therefore, even hand and leg don't have a fixed meaning. It can actually be a body part or it can be a prosthetic. When we treat a quantum particle as a face of something, then we do not stop treating it as a part. It is just not like a classical part which is independent of the other parts. Therefore, a quantum particle is a part and yet not a classical part. It is like a face which is also a part and yet not an independent part. Similarly, when we treat a quantum particle like a dimension, we don't stop treating it as an object. It is just not a classical object, which is independent of other objects. Therefore, a quantum particle is an object and yet not a classical object. With these two examples, we can generalize the quantum problem by saying that everything has to be understood in three different ways, although seen from different perspectives. These three ways are space, dimension, and object. A quantum particle is an object, a dimension, and a space. There is no such thing in classical physics where either something is a particle or a dimension or a space. But quantum particles are simultaneously objects, dimensions, and spaces, although we cannot see them as three things at once. We have to use different perspectives to alternately see the same thing as an object, a dimension, and a space. This requires us to conceive space itself in a hierarchical manner, which has never been done in classical physics. We can visualize a hierarchical space like an inverted tree with a root, many trunks, branches, twigs, and leaves. From the perspective of the leaf, the twig looks like a space because the twig contains many leaves. From the perspective of one twig, another twig looks like a dimension because they are all emanating from a single branch. Finally, from the perspective of the branch, the twig looks like an object. Thus, we get three perspectives, namely from a leaf, from a twig, and from a branch. We can also call this the higher level view, the peer level view, and the lower level view. From the higher level, the lower level looks like an object. From the peer level, another peer level looks like a dimension. From the lower level, the higher level looks like a space. Hence, everything is at once an object, dimension, and space, but from three different perspectives. We can never conceive this type of reality in classical physics because something is either an object or a dimension or a space. The same thing cannot be simultaneously an object, a dimension, and a space. Hence, quantum particles become inconceivable when we think of them in terms of classical concepts. Since we are talking about the semantic view, therefore, we can illustrate this problem through an ordinary example of seeing through our eyes. The eye is a concept called sight. The sight can perceive the properties of shape and color. Within the class of shapes, there are shapes such as hexagon, pentagon, square, and triangle. Within color, there are shades like red, green, blue, and yellow. Now, when we look at color from the perspective of one shade, such as green, then color becomes a space because within color, there are many other shades like red, blue, and yellow. However, if we look at color from the perspective of shape, then color is a separate dimension than shape. Finally, if we look at color from the perspective of sight, then color is an object within sight, just like green was an object within color. Hence, the same thing is three different things. But to see those three things, we have to look at the same thing from three different perspectives. We can call color a space, a dimension, and an object. This is the fundamental tripartite nature of all concepts. It arises because concepts are organized in an inverted tree structure. If reality is word meaning, while meanings are organized in an inverted tree structure, then each meaning can be treated in three different ways as object, dimension, and space. Since this is inconceivable in any classical physical theory, therefore classical physics can never model word meaning reality. We have earlier discussed the three meanings of a word, namely that each word is an individual thing like an object, then it is some meaning, and finally it has a reference. The same tripartite structure of a word can be extended even to just meanings. For instance, the concept of color is a meaning, but it looks like an object from the perspective of sight, it looks like a dimension from the perspective of shape, and it looks like a space from the perspective of green. Since we cannot see the same thing in three ways at once, therefore we have to hop our minds from one place to another to see the different phases of color. First, we have to go to green and then see color from there. Then we have to go to shape and see color from there. Finally, we have to go to sight and see color from there. By this hopping from one place to another, we can see the same thing in three different ways. Thus, we can understand that color has three phases. We cannot see those phases at once. We have to hop from one place to another to see those phases. We can rephrase the same problem in pure mathematical terms, namely that the same thing is a set, a class, and an object. For example, color is a set, class, and object. Color is a set because it contains shades like red, green, blue, and yellow. Color is a class or a type of thing from the perspective of shape, and color is an object from the perspective of sight. Now we have transformed a physics problem into a mathematics problem. The problem says that the same thing must be a set, a class, and an object. This means that when I speak about the word color, I could be referring to a collection of shades, or referring to a dimension or type, or referring to an object. Modern set theory talks about sets and objects, but there is no method to ensure that we can collect in a set only one type of thing. For example, if we want to make a set of colors, then I should only pick shades like yellow, green, and blue. And I should not pick horses, cows, or shapes like square and triangle. This requires an immanent type of quality in each thing. But objects in set theory don't have anything immanent in them. For example, there is no such thing as an immanent color in yellow. If we actually accepted the immanence of color in yellow, then we will get a contradiction because color will now both be inside yellow and outside yellow. To avoid this contradiction, color is treated just outside rather than inside. However, because of this treatment, we cannot know that yellow is a color, and hence we cannot aggregate it into a set of colors. Sets in set theory are constructed arbitrarily because the basic construct of a set theory is an object. We cannot construct a set without an immanent type, and we don't have immanent types, and hence we cannot have properly constructed sets. Since we cannot talk about types or dimensions, and hence we cannot even construct sets that contain just one type of thing. Therefore, modern mathematics can never deal with the problem of one thing being three things, because the whole system of mathematics is constructed from objects rather than concepts. If we don't have concepts, then we can never talk about multiple concepts, higher and lower level concepts, and how a word is the symbol of a concept. Thus, object thinking is the root cause of why we cannot treat one thing as three things. Once we understand the three views of a quantum as a set, class, and object, then we can understand the basic paradoxes of quantum mechanics, namely why the same thing is called a wave and a particle. The wave is actually a space view of quanta. In this space, there are dimensions like the faces of a square or triangle, which are like dimensions. Due to these dimensions, the quantum particles are said to be entangled because removing one particle changes all the particles. So they cannot be called independent of each other. Finally, each dimension is also an object, which is why it is called a particle. Thus, in the space perspective, the quantum is a wave. In the object perspective, the quantum is a particle. And in the dimension perspective, the quantum is entangled with other quanta. The paradoxes of quantum mechanics cease to be paradoxes when we understand that the same thing is three things, and these three things cannot be observed or known simultaneously, but they can be known one after another, so they are true, and yet they appear to be mutually opposite descriptions. The situation with the three perspectives is just like the situation with a pen being called a toy, weapon, and doorstop. A pen is not simultaneously a toy, a weapon, and a doorstop, but it can be so alternately. Similarly, a quantum can be alternately described as a space, dimension, and object, because this is the nature of all concepts. With this understanding, we can say that the entire universe is quantum mechanical. There is simply nothing classical mechanical. And yet, something seems classical mechanical because the aggregation of quanta is hierarchical. For instance, we can aggregate all shapes into a set of shapes and separately aggregate all colors into a set called color. We can then aggregate shape and color into a set called sight. This is hierarchical aggregation in which we don't mix shapes with colors. As a result, we don't get a single quantum mechanical ensemble. We rather get a hierarchy of bigger and bigger ensembles. In this hierarchy, the bigger ensembles appear loosely entangled compared to the smaller ensembles that seem tightly entangled. We can illustrate this problem with that of a book in which letters are combined to create words, which are then combined to create sentences, which are then combined to create paragraphs, which are then combined to create the chapters, and ultimately the chapters are combined to create a book. The meaning of a word depends on each letter. Even a minor change in the letters can drastically change the meaning. But this interdependence occasionally reduces as we rise up the hierarchy of integrations. In some cases, we can delete a paragraph without drastically altering the meaning of the whole book. In other cases, we can completely delete a chapter without drastically changing what the book is saying. The ability to remove something without changing the rest of the things is classical mechanical independence. Factually, classical mechanical independence is just an approximation as we get to bigger and bigger ensembles. It is not a universal fact. Therefore, the so-called Planck's constant is also not a constant because the entanglement can be greater or smaller. When we come to the level of a planet, for example, we can say that the death of a person doesn't affect everybody else in the world. It could be approximately true. Certainly, the death of a very important person affects many people, but the death of a less important person affects others less. Similarly, even the removal of a million less important people would create noticeable effects. If we remove a billion less important people, then the effects will still be drastic. Therefore, even the whole planet is a quantum ensemble. It is not a classical system because removing something from the ensemble changes the other parts of the ensemble. However, the quantum properties of a planet are not seen if we restrict ourselves to removing a few less important people. That effect will be seen if we remove a few important people or many less important people. When the quantum effects are not noticed, it doesn't mean that there is no entanglement in the so-called classical mechanical world. It just means that there is no such thing as a Planck's constant that fixes the entanglement. We can also say that the Planck's constant tends towards zero as we go to bigger and bigger ensembles, but never becomes precisely zero. A large system is not as much affected by the loss of a small part as a small system is affected by the loss of the same part. So a large system seems classical while a small system seems quantum. Finally, even a large system can be highly entangled because there is no rule that only small systems must entangle. The lower entanglement of larger ensembles is just a general trend of the stability of large systems upon the loss of smaller parts. But it is not always true. Sometimes removing some paragraphs or chapters from a book can drastically change the meaning of the book, although the general trend is that such a thing would not happen. Many people might look at the hierarchy in a book and say that the book is not one thing. Rather, it is reducible to the chapters, then to the sections, then to the paragraphs, then to the sentences, and finally to the words. This is not actually true, but to understand why that is so, we have to understand the Vaisheshika system of organization. Vaisheshika is a system of Vedic philosophy that identifies three categories called Dravya, Guna, and Kriya. They correspond to nouns, adjectives, and verbs in a language. The noun represents a class, while the verbs and adjectives are empirical methods to identify the class. The class is not reducible to the adjectives and verbs because, as we have discussed, there are essential core and kernels of anything surrounded by the periphery. Similarly, for each class, there are core adjectives and verbs along with the periphery. For example, the class car can be identified by its adjectives and verbs. A car's adjectives include its various parts such as a chassis, steering, wheels, and engine. But none of these adjectives are necessary. For example, an electric car may not have a combustion engine. A self-driven car may not have a steering. A car may have fewer or greater number of wheels. Therefore, what we call a car is primarily driven by its shape and size. Changes to that shape and size make us call the vehicle a truck or a bus. However, even as something looks like a car, it may not work as a car. It may even have something that looks like an engine, wheel, or steering, but they may not work as expected. Therefore, we have to determine if the parts of the car do their respective functions and the car as a whole does what it is expected to do. Since the parts of the car may not be present, therefore the functions done by those parts may also be absent. And yet, the car as a whole must work. Thereby, we define a class such as a car in two ways. A, it looks like a car, and B, it works like a car. Looking like a car is the car's adjectives, and working like a car is car's verbs. If some part of the car becomes dysfunctional and stops working, we don't immediately say that this is not a car. We try to repair or replace the dysfunctional part and it becomes again a car. This definition of a class is generalized in Vaisheshika as Dravya, the noun car, Guna, the adjectives of the car, and Kriya, the verbs of a car. Something is a car when all three are present. If some part of the car is missing or dysfunctional, then we don't immediately call it not a car. We try to fix it so that it becomes a perfect car. We don't try to fix a cycle to become a car. This is because we see the whole thing along with its parts and compare it to an ideal car. If the comparison shows great similarity, then it is called a car. Otherwise, it is called a cycle, truck, bus, and so on. The tripartite ontology of nouns, verbs, and adjectives is used in Vedic cosmology in the construction of space. The adjectives and verbs constitute a flat space whose center is the noun. The noun requires some kernel, minimum, and basic set of adjectives and verbs to be called a car. For example, we might not have an air conditioner, music system, or a hands-free system in the car. It will still be called a car and yet a bare bones car. Then we can progressively add more features to the car to produce better and better cars. Each addition of features to a car constitutes some additional adjective and a verb. Thus, from a bare minimal car, we can construct an advanced car. After this flat space is constructed, the whole flat space is simply the class called a car. And yet, even the innermost core of the class is called car. The difference is that the innermost core is the most essential functional car. The outer portions are better and better cars. And finally, the whole thing is just the class called car. Therefore, by space, we just mean a class of things. Within that class are many subclasses. The more advanced subclass is on the outer periphery. The less advanced class is on the inner part of the class. This space is used to describe many different life forms. For example, the advanced human forms are within the human category and yet more advanced than humans in the inner part. This advancement is not always a good thing. As we get used to a more luxurious car, we don't want to leave the car. We can easily leave a bare bones car, but not an advanced car. Therefore, the innermost portion of the earthly space is considered the best for spiritual advancement because the body and life can be renounced easily. The outer regions are not good for spiritual advancement because they are like more materially advanced cars that are hard to renounce. The inner and outer concentric circles of a car class can be treated in three ways. First, they can be called a space. Second, they can be called a dimension. Third, they can be called an object. Even cars are classified into low segment, mid segment, and high segment. Each segment has a different price range. They are meant for different classes of customers. Everything can be classified in the same way and it becomes something useful to a different customer. Space is therefore simply the domain of many customers trying to purchase one thing in many different subclasses. Once we understand how a space is created by nouns, adjectives, and verbs, then we can understand that each location in space is a noun, adjective, and verb. We call these locations words. There is a simple way to say something, and there is a complicated way to say the same thing. The complicated way is not always unnecessary, it just communicates more nuances. For example, we can simply say that I am happy, or we can say that I am thrilled, excited, motivated, inspired, exuberant, enraptured, enlivened, electrified, and so on. Similarly, we can simply say that I am sad, or we can say that I am depressed, morose, dejected, dissatisfied, discouraged, downcast, disheartened, disappointed, crestfallen, and so on. Happy and sad are simple words. Other words are complicated. This is not unnecessary complexity. The complicated words are just like a car with an air conditioner, music system, and hands free. The reality is that sometimes when we say I am happy, what I mean is that I am motivated to do something. At other times, I mean that I am just excitedly looking forward to something. Similarly, when I say that I am sad, then sometimes I mean that I am depressed and unable to do anything. At other times, I mean that I am disappointed, but I will continue doing my work. Thus, the word happy is like a wave function, and the words thrilled, excited, motivated, inspired, exuberant, enraptured, enlivened, electrified, and so on are the varied meaning eigenfunctions. Each type of meaning is seen in one case and not in other cases. This is because even as I am saying that I am happy, I don't mean the same thing in all situations. The same goes with sad. It doesn't mean one thing. It means something different in different contexts. Likewise, each word has a different effect in a different context. Sometimes looking at my happiness, an envious person may become depressed. At other times, a clean hearted person may become happy on seeing me happy. I might also show my happiness to a clean hearted person and hide it from an envious person. Accordingly, the same word represents different adjectives and verbs in different contexts. The word is just denoting a noun, but that noun has almost infinite variety within it. The variety of adjectives and verbs is called the position and momentum representations of the word. There is one thing, namely the noun, but it has many interpretations and effects which are called the adjectives and verbs of that noun. Again, we can see that one thing is many things by default. It changes its nature based on the time, place, and situation. Having looked at these fundamental principles of the semantic way of viewing reality, we can now go back to a simple question. What is atomism? We can say that it is about breaking something big into something small. However, there are two conceptions of atomism in classical and quantum mechanics. In classical mechanics, we try to break something into independent pieces. But in quantum mechanics, we try to divide something into dependent pieces. A simple example is that of cutting an apple. Normally, we mean that if we cut an apple into two halves, then you can eat one half and I can eat the other half. This is classical cutting. But there is a quantum cutting in which we can divide the apple into its properties like smell, taste, shape, color, texture, weight, size, nutrition, and so on. Even when we cut the apple into two halves and each person eats one of the two halves, each person gets all the properties of smell, taste, shape, color, texture, weight, size, nutrition, and so on. Each person can say that taste is different from smell, but we cannot separate the apple's taste from the apple's smell. We can cut the apple into two halves, but we cannot separate the taste and smell from those halves. Therefore, there are two kinds of cutting. Classical atomism is based on cutting the apple into pieces. Quantum atomism is based on distinguishing the taste from the smell without separating the taste from the smell. Since all scientific concepts of atomism are based on cutting the apple into pieces, therefore science cannot understand how taste and smell are distinct and yet not separable. If we want to remove smell from the apple, it will change the taste of the apple, the nutrition of the apple, the color of the apple, and so on. Hence, quantum cutting is not really cutting the apple. It is rather distinguishing things within the apple without separating them from each other. This now leads us to a simple understanding of quantum collapse. The understanding is that our consciousness observes the apple one after another. Sometimes our focus goes to the apple's color, then it goes to the shape, then it goes to the smell, then it goes to taste, texture, nutrition, weight, and so on, one after another. Since I can exclusively focus just on taste, therefore I can say that taste is distinct from smell. But distinctness is not separability of taste from smell. Two things are distinct and yet not separable. This, as we have talked in the previous videos, is bhed abhed. Taste and smell are distinct, therefore there is bhed. But taste cannot be separated from smell. This is abhed. Thus, quantum entanglement is nothing but bhed abhed. It has been called inconceivable because everyone is thinking in terms of cutting the apple into pieces. They cannot understand how the cut pieces of the apple cannot be called just one thing. This is because bhed abhed is not talking about cutting the apple into pieces. It is talking about distinguishing the smell from the taste without separating the two things. Taste and smell are just two faces of the apple. We can see one face at one time without separating the face from the other face. But if we do separate the faces, then we will have to change all the faces. Thus, Bhed becomes clear when we talk about quantum cutting and contrast it to classical cutting. The one by one observation of the properties of an apple is called quantum collapse. It is like perceiving the taste, smell, color, shape, size, weight, and so on, one after another. It is not cutting the apple into pieces, but because science cannot think of anything other than cutting the apple into pieces, therefore it cannot understand quantum collapse. Quantum collapse can be driven both by the observer and the reality, as we have discussed earlier in the video entitled The Problems of Realism and Idealism. For example, some observer may have a natural preference towards taste rather than smell. He might bite into the apple and taste it before observing that the apple has a good smell too. In this case, the collapse is driven by the strong observer preference towards taste rather than smell. The bidirectional underdetermination is resolved in this case by the observer preference because the observer may be very hungry and may quickly bite into the apple before he tries to find the smell of the apple. In this case, the observer has forced his choice on the apple. But it is also possible that the observer is not very hungry and the fruit or the apple has a strong fruity aroma. In this case, the observer will focus on the smell, then develop a desire to taste the apple, and therefore the smell precedes the taste and becomes the cause of tasting. Unlike the case of a hungry man biting into the apple before smelling it, in this case the apple is smelt before being tasted. Thus, when the observer is hungry, then he forces his choice to taste on the apple. But when the observer is not hungry, then the apple forces its choice to make the observer smell before tasting it. In the former case, the bidirectional underdetermination is resolved by the observer, but in the latter case, it is resolved by the apple. Therefore, we cannot say that collapse is always driven by the observer or the reality. John von Neumann created an interpretation of quantum theory in which consciousness always collapses the quantum because in Western thinking, reality has no choice. Reality is considered inert, dead, lifeless, and objective. Hence, Neumann attributed choice to consciousness. This is not always true. A hungry man forces his choice on the apple to taste it before smelling it, but a satiated man is motivated to taste the apple after smelling it. Hence, consciousness can be said to collapse the quantum wave function, but that choice is not just in the observer. It is also on the reality being observed, because even that reality is a person and not something impersonal. Based on the process of quantum collapse, we can now talk about the underlying causality. Quantum theory recognizes two kinds of quantum particles called fermions and bosons. In the apple example, the fermions are properties such as taste, smell, size, shape, weight, texture, and so on. The boson is the bidirectional movement of the choice. Either the observer selects something in the apple or the apple selects something in the observer. This process of selection is a choice rather than a force because the bosons are not emitted deterministically. A force has to be deterministic, but a boson's emission is not deterministic. Therefore, there are two levels of indeterminism, namely fermion indeterminism, by which taste instead of smell is preferred by a hungry man. But there is also a boson indeterminism in which the choice of taste over smell is communicated from the observer to the apple to indicate the preference. Both kinds of indeterminism look the same in current quantum theory, but they are not the same. The boson is the primary trigger by which the fermion is observed. Therefore, we can say that the fermion is matter while the boson is force. But neither is matter a fixed reality, nor is the boson working deterministically. Both are possibilities to be used through a choice. The problem of choice troubles scientists a lot. They say that if the world was simply moving according to choices, then we will get idealism and solipsism. Very specifically, when I sleep, my digestion, circulation, breathing, and immunity must stop because I am not observing the reality, and hence reality cannot be governed by my choices. The answer to this problem is that there are three kinds of choices triggered by three agents, namely time, nature, and observer. Time and nature are also observers, so their action is also a choice. But for the present discussion, we will not go into that detail and simply treat time, nature, and observer as three different kinds of choices. When we sleep, then time's and nature's choices keep the body working. Sleeping doesn't mean the end of digestion, circulation, breathing, and immunity because nature and time are also exerting their choices. Then, when I wake up, nature and time often exert choices against my choices. For example, although I might want to be rich, all my wealth may be stolen. Even though I want to be recognized, I might live in ignominy. This type of choice is controlled by what is called karma in the Vedic text. It is the result of past actions. Finally, there are occasions when I can move my hands and legs as per my will. Thus, we cannot limit choice just to the observer because everything is not moving like my hands and legs being moved volitionally. They are also moving lawfully, such as during digestion, circulation, breathing, and immunity. They can also be moved abruptly due to karma, and they can be moved due to my will. Thus, choice also comes in three forms. This choice interacts with the boson. The boson is called prana in Sankhya. It is like a force, and yet it is not observable matter. The basic distinction between matter and force exists in Vedic texts as the observable part of reality and the force that makes this reality selectively and occasionally observable. Prana in Sankhya acts through both senses of knowledge and action, which are like adjectives and verbs. Thus, sometimes time and karma force us to do things we would not do otherwise. At other times, we can control the prana by our will. This tripartite nature of control of prana is described in many places in the Vedic texts. Here I have cited one such description from the Srimad Bhagavatam. This is not the only place, there are many such citations in the Vedic texts. They talk about three causes of the world, which are called kala or time, karma or consequences of previous actions, and swabhava, which is our nature dictating some choices. It will take a long time to discuss each of these in detail, so we will not do that here. But it is worth remembering that there are three causes, not just one. Therefore, the problem with choice that is said to follow the John von Neumann interpretation doesn't follow because nature and time are also persons. They have choices and yet they are not our choices. By talking about three kinds of choices, the body can work deterministically, erratically, and volitionally. These three are the results of three kinds of choices. We can now summarize the quantum problem and why it is unsolvable in modern physics. There are four main reasons for this, which are noted here. First, modern science treats everything as objects, when everything is object, dimension, and set. The set theoretic constructs in modern science disregard the role of dimension and hence they do not construct sets as groups of similar types of things. They just aggregate things randomly. Even if choice is assumed through the axiom of choice, it cannot be explained in science. Therefore, modern science is still under the grips of Aristotelian logic, in which one thing is just one thing. One thing cannot be three things at once without creating a contradiction. Second, since choice is very important to the collapse problem, therefore, many serious issues are created. The first issue is philosophical because since antiquity, Western thinking has depersonalized nature and everything is built on the assumption that time and nature are not persons. The second issue is more pragmatic that if we allow choices, then reality will not work when we are not observing it, or it will work so randomly that we can never form the laws of nature. This assumes that people with choice are not moral people, they just behave erratically. This is again a cultural assumption. Factually, those who ascend to powerful positions are those who act responsibly. We cannot say that choice simply means erratic and lawless behavior. Third, there is no conception of causality in which three kinds of choices, namely that of time, karma, and nature, act cooperatively and consistently. The fact is that our will is not supreme. Our will acts when time and nature don't force us into a corner with determinism. But that is not universalization of our choice, nor is it the universalization of determinism. Without the conception of how three causes join to produce a single effect, we cannot account for how the quantum collapse occurs. That is the complete dead end for science. Finally, what brings together nature, time, and choice? Who decides what takes priority when? How can a person sometimes go against the grain of nature and time? From where can we get the willpower to fight the reality being forced upon us? This in turn requires God. Since God is programmatically outside science, therefore, this is also a dead end for science. Thus, the quantum problem forces four types of inconceivability. None of these four problems can be solved in modern science. Hence, quantum mechanics is a total dead end for science. It is not just the presence of soul and God that is the problem. There are even more fundamental issues of logic under which one thing is many things, and the depersonalization of reality through objectification and mathematics to claim that the world is simply objects governed by mathematical laws. To solve the quantum problem, we have to throw away the entire ideological baggage of Western thinking that began with Greeks depersonalizing nature in philosophy, which was then carried forward in Christianity. We have to throw away the entire baggage of logic and mathematics that began with Aristotle, saying that one thing is only one thing. When the entire history of modern science is riddled with so many fundamental problems, then we cannot hope to get an answer. That doesn't mean there is no answer. The answers are amply present in the Vedic texts. These texts have been studied under Western influence, pretty much like the Bible, Torah, and the Quran, which have nothing to say about any scientific subject. By equating the Vedic text to Bible, Torah, and Quran, people disregarded the pristine scientific content in these texts. If we are serious about studying the Vedic texts, then we can find all the answers to the unsolved problems of modern science. That is actually the main purpose of making all these videos.